All right, back for day 8 of Advent of Code. Here we go. Okay, it's another grid. What do we want to do? How many unique locations within the bounds of the map contain an anti-node? Anti-nodes. Okay, I need actually to read the whole thing. Each antenna has a specific frequency. These antennas, anti-nodes, perfectly in line with 2 antennas at the same frequency, but only when one of the antennas is twice as far away as the other. For any pair of antennas with the same frequency, 2 antinodes. Ah, gotcha. What's the question? How many unique locations contain an antinode? Okay. Got it. How big is this? I don't know, and I don't think it matters too much. Let's just go through all possible locations. Can an antinode be at an antenna? It's not clear. But I'll just assume something and go with it. Okay. So the question is going to be, let's make our, so first let's assemble this. Okay, now try all possible locations, and then we're going to check to see if for any frequency, well, I guess first we should just throw that in there, and then if I need a distance function, no, we need to be, sorry, well, let me just check this first. We need to be in the same row or column as both of these. If I is equal to v0, 0 and j v1, 1, or that's one of the 2 possibilities. Or I is equal to v0, 1, and no, I is the first coordinate, 1, 0, and j is equal to v0, 1. I think this is it. Then we check the distance, distance from ij to v0. I'll write that function later. I'll write it now. I'll write L1 distance. Okay. If d1 equals d2 times 2, or d2 equals d1 times 2, hopefully that works. Oh, shoot. Oh, there can be more. Okay, we need to try all possible pairs of these. Ugh, this is so nasty. Okay, and then this is now going to be v1, whoops, no, v1, v2, v2, v1, v1, v2, run. Let's get the PyPy going as well. What are we on, 8? 52 is my answer? That seems too small. Let's try it. Not 52. Let's try sample input. Man, I just cannot catch a break and write code correct the first time. 12 locations. Well, that's not right. What am I breaking out of? I could be double counting, so that's actually not good. But I'm undercounting, not overcounting. That should make it lower. They can occur at locations that contain antennas, so that part's fine. Oh, I did not read this right. Perfectly in line. Oh, in line means not just, oh god. Oh, that's so annoying. Okay, so to check if these are collinear, what do I want to do? I guess what I can do is I can check the slope. That's not quite going to work. How do I easily check if V1, V2, and IJ are collinear? If I was better at geometry, this would be a lot easier. But I guess we'll do okay, so that's a vector. I can do another vector, and then I want to check if these vectors are like scalar multiples of each other. Let's do, yes, V1 to V2, and then let's do V1 to cur. Yeah, I minus V1, 0, J minus V1, 1. And then now I want to check. I guess I could just do DC perp is going to be minus DC's 1. Can I just do this? Can I just take a dot product now? Then they're orthogonal. And then if the perpendicular is orthogonal, then they're collinear, and we are all good. Check the distances, good.add. The distance is, I assume it's L1 distance, but at this point we just have to send it, I think. 20. That is still really not right. Now it's time to print out a plus an antenna overlapping the topmost A frequency antenna. Let me reread the double the distance thing. Perfectly in line with two antennas of the same frequency, only when one of the antennas is twice as far away as the other. Oh, this is not L1 distance, it's L2 distance. Okay, that makes this, shoot, I'm gonna need to take a square root here. I might have already had that imported. And then we'll need to do a like epsilon thing to account for rounding, because float math is not going to be great. D1 times 2. Try that. What did I do wrong? I keep starting to write this debug thing and it, wow, that didn't do anything. Let's get rid of that one for starters. Okay, let me write the debug thing now. If ij ain't good, I think I messed up my, oops. Am I putting them at the actual antinodes themselves? It seems like I'm putting one on the 0 antinode, and I'm not sure that's right. Oh shoot, I got rid of this check. 14? 14, okay. I'm probably not gonna leaderboard with this, but you never know. 394? Did not copy. Right answer, 659. Wow, that was really bad. Any grid position exactly in line with two antennas regardless of distance. Some of the new antennas will occur at the position of each antenna. Okay. So I just think I don't need this check anymore. Is that right? That feels too simple. 1277? Rank 249. Okay, wow, that was a very simple part 2. I don't know why. Was there a trick to part? Oh, right. I think a thing you could have done for part 1. I'm not thinking about this carefully yet, but you could just take 2 of these and then immediately. Yeah. If you just move this amount of distance, like this vector distance, over in either direction, then you get the 2 points exactly, and that's why they said there's exactly 2. Whereas I wrote this whole thing, and because I did it this whole disgusting way, it made my part 2 really easy. But yeah, did not make part 1 go well. I'm curious if LLMs were able to get this. 14 seconds. Well, that answers that. Yeah, I was sort of thinking while I was doing it, like, oh, maybe this will be a little bit hard for the large language models. But I guess it's pretty clear. I don't know. I don't really have a great mental model yet for what they can and cannot do. Like when it comes to algorithmic problems, at least. So I guess we'll see in the coming days. I really gotta get my PyPy set up a little bit better. It didn't really matter for this. But like the fact that I have to keep commenting out code in order to get PyPy to run kind of sucks. I should really just have some check here and like import this only if PyPy, if we're not running in PyPy or something. Or not just import that, but like my general things that like paperclip. Also, it didn't copy. Oh, it's because I was doing this. I was like, why is it not copying my answer? Okay, we can get rid of that debug. Cool. Yeah. I guess I can briefly explain my solution while I modify it to get both parts. I'm going to call it part 1 and part 2 because P1 and P2 sound like points. So this was my part 1. And then just in general, when we enter this, we're going to have part 2. And then I guess in this case we can definitely break, but we can't break here technically. Then part 1. Sorry, I was going to explain it while I was doing this, but I got a little absorbed in just doing this. And I'll leave the debug print in here. I also maybe should I keep rewriting this debug print from scratch, and maybe I should just have it like ready or something. So the thing that I did was I just went cell by cell, and then checked all possible pairs of the same frequency, what are they, receiver, antenna, and then asked, does this condition meet the requirements to be an antinode? And that, so the first bug I wrote, I guess, was like, I don't know, I like read this kind of weirdly. I didn't really look at this example very carefully at all. I thought that it had to be like, I don't even know how to describe it. I thought that if we had something like this, then maybe I'll put this in a different column. I thought that they had to be in the same row as one and the same column as the other. I'm not really sure why I thought this. Oh, I thought this was because I read perfectly in line with 2 antennas of the same frequency. I read this and I was like, oh, lines can only go vertically or horizontally. Not actually true, but you know, that's what I was thinking. I guess if my interpretation was really the case, then it should have been a tip-off because it said that there's exactly 2 antinodes. And there would like not be in this case because of the requirement that, that one of them is twice as far as the other. Because of my assumption, I wrote L1 distance because I thought that like they would always be in line with each other. And because of that, it would be like, so what is this? This is distance 1, 2, 3, 4. So 4. This is 1, 2, 3, 4. Yeah, okay. And then this would be distance 2. I thought that if it were like this, then we'd have an x here, and if it were like this, then we would have no x anywhere. And or at least that's the logical conclusion from my interpretation, which is just wrong. Anyways, enough about like what I did wrong. What I actually, the way I implemented this, in particular, the perfectly in line with two antennas the same frequency, I did some geometry, linear algebra, if you could call it that, in order to check this, and man, is it disgusting. So what I'm doing is, maybe it's time to whip out the MS Paint here. The MS Paint and the tablet. Let's see. Okay, cool. Yeah, so what I do is if we have two nodes that we're considering, call this one V1 and this one V2. If you want to check if some other candidate point, C, is in line with both of them, what you want to do is you want to check if these 3 points are collinear. And one way to do that is to draw these two vectors and then ask, are these vectors parallel? If C is collinear, then they will be parallel and life will be good. If they are not, then they won't be parallel. And the way to check if they're parallel, so in 2 dimensions this is nice and easy. In 3 dimensions, I would have to think harder. I might need like a cross product. What do you do in 3D? Yeah, I think in 3 dimensions the magnitude of the cross product tells you this or something. I don't really remember. Yeah, I guess I'm lucky this wasn't in 3 dimensions. But the thing I did was just that, like, you can in two dimensions you can easily construct a perpendicular vector to another one. You could construct a perpendicular vector by just if this is x, y, then the perpendicular vector is just going to be minus y, x. So I guess like I'm not working this out. I didn't actually work out if this is the correct direction, but it doesn't really matter. Like this transformation is either rotation 90 degrees right or 90 degrees left. I don't remember which one. The point is this is definitely perpendicular. And once you have a perpendicular vector, it's easy to check if this vector is perpendicular to V1 to V2 because you can just take a dot product. If the dot product is 0, then, so I don't know what I want to call this one. I'll just call it SXSY, sure. If the dot product of these two is 0, then these two are perpendicular, which means that these two are parallel. So that's exactly what I did here. I got my dv, which is this vector. I got my dc, which is this vector. I got my dc perp, which is this vector. And then I take a dot product. And if the dot product is 0, then they're perpendicular. Cool. So that was how I did that. And because I did it this way, it made part 2 really easy. Because all I had to do was like remove another check, remove the check on the distances, and it just worked. I guess the only other gotcha is that if you're doing like floating point math, like taking square roots to compute your distances and whatnot, then you really want to have some tolerance. If you don't, then you might end up with like 2 floating point numbers that are really close to a factor of 2 different, but they're not. This is specifically because they're a factor of 2 different. Let me actually see if this works. I suspect it won't, but like it might be off by something. Oh, you know, I guess it's fine. I guess I worried too much. If the numbers were bigger, I feel like this might have been a problem. But anyways, I'll leave it this way because that was how I wrote it initially. But yeah, that is day 8 of Advent of Code. Another day of no leaderboard, but you know, these problems are still pretty easy. I'm hoping we'll get some harder ones, and then maybe I can climb up the leaderboard a little bit. But we'll see. I will see you all tomorrow.